Hello friends, I am Dr. N.J. Suryavanshi, Department of Industrial Chemistry, Art Science and Commerce College, Chikaldara, District Amravati, Maharashtra. Today we are going to see surface chemistry. Before understanding surface chemistry, let's first understand the phenomenon of adsorption. When a solid surface is exposed or open to a gas or liquid, molecules of this gas or liquid concentrate or accumulate at the solid surface. Definition of adsorption: the phenomenon of concentration of a gas or liquid molecules at a solid surface is called as adsorption. The substance that concentrates at a surface is called as adsorbate, and the solid at whose surface the concentration takes place is called as adsorbent. Adsorption versus absorption. Adsorption and absorption are two different terms. Adsorption means concentration at surface only. That is, adsorption is a surface phenomenon. For example, when a crayon chalk is dipped in ink, it is get adsorbed on the chalk surface. On breaking the chalk, it is found that it is white inside and only colored at surface. Absorption is penetration into the body of solid. That is, absorption is a bulk phenomenon. For example, water is get absorbed by a sponge and distributed throughout the sponge. Mechanism of adsorption. Atoms or molecules of a solid surface act as the surface molecules of a liquid. As these molecules are not surrounded by atoms or molecules of their type on all the sides, they possess unbalanced or residual attractive force and hold the adsorbate molecules of liquid or gases. The adsorbed atoms or molecules can be held on the surface of a metal by physical forces, that is van der Waals forces, or by chemical forces due to residual valence bonds. Types of adsorption. Adsorption of gas or liquid molecules on a solid surface takes place into two types: physical adsorption and chemical adsorption. Let's first see physical adsorption. This type of adsorption takes place when the gas molecules are held on the solid surface by van der Waals forces or bonds. It is also known as van der Waals adsorption. For example, adsorption of hydrogen or oxygen on charcoal is a physical adsorption. Chemical adsorption or chemisorption. This type of adsorption takes place when gas or liquid molecules are held on the solid surface due to the chemical bonds. The bonds may be of ionic or covalent type. For example, hydrogen is chemisorbed on nickel catalyst surface. Hydrogen molecule is first adsorbed by van der Waals forces and then dissociates. Thus, hydrogen molecule gets chemisorbed by nickel. Now let's see the factors affecting adsorption. The first factor is surface area. As adsorption is a surface phenomena, extent of adsorption depends on surface area. Increase in surface area of adsorbent, increase in the amount of gas adsorbed is observed. Thus, if a catalyst is finely divided or in the powder form, more surface area is available for adsorption. The second factor is nature of gas. If a gas is easily liquefiable, more easily it will be absorbed. For example, only 1 gram of activated charcoal can absorb 380 milliliter of sulfur dioxide, while chemisorption will not occur if there is a possibility of reaction between the gas and the solid. The third factor is reversible character. Physical adsorption is reversible as it is due to the weak van der Waals forces. However, chemical adsorptions are irreversible as they take place due to strong chemical bonds. Another factor is effect of temperature. Physical adsorption occurs rapidly at low temperatures but decreases with increase in temperature. While chemical adsorption, as like chemical reactions, increase with increase in the temperatures. Thus, often physical adsorption on rise in temperature turns to chemical adsorption. The another factor is effect of pressure. Increase in pressure causes increase in adsorption, while decrease in pressure decreases in adsorption. The last factor is thickness of adsorbed gas layer. In physical adsorption, at low pressure, only one molecular layer of adsorbed gas is formed, while at high pressure, multi-molecular layer may be formed. Now, let's see what are the applications of adsorption. Adsorption phenomenon has many applications. Some of these are: first, production of high vacuum. If a partially evacuated vessel is connected to a container of activated charcoal cooled with liquid air, the charcoal adsorbs all the gas molecules in the vessel. Thus, a high vacuum is formed in the vessel. Silica gel may also be used as the adsorbent. Second, gas masks. All the gas masks contain an adsorbent like activated charcoal. These adsorbents remove poisonous gases by adsorbing them on the adsorbent surface and thus purify the air for breathing. Third, heterogeneous catalysis. In heterogeneous catalysis, the reactant molecules are first adsorbed on the catalysis surface and then formed adsorption complex which then decomposes to product. Fourth, removal of coloring matter from solutions. Animal charcoal removes colors of solutions by adsorbing the color impurities. Thus, in manufacture of cane sugar, the colored solution is made clear by treating with animal charcoal. Fifth application, chromatographic analysis. Mixtures of small quantities of organic substances can be separated with the help of chromatography by the principle of selective adsorption. Sixth application, froth flotation process. The froth flotation process is used for the separation of minerals in the ore from the impurities like earthy matters. The low-grade sulfide ores like lead sulfide, zinc sulfide, and copper sulfide are first mixed with oil and agitated with water containing detergent. When air bubbled in this solution, the bubbles adsorb mineral particles weighted with oil and thus they rise at the surface while earthy matter and water remain at the bottom. Surface chemistry plays an important role in our daily life. For this, we have to understand first colloid science. While understanding colloid science, let's first see colloidal state. A substance is said to be in colloidal state when it is dispersed in another medium in the form of very small particles having diameter between 10 raised to minus 4 to 10 raised to minus 7 centimeter. Then colloidal solution. A colloidal solution may be considered of following three components. Dispersed phase, it is the substance which is dispersed. Dispersed medium, it is the medium in which dispersed phase is present. And a stabilizing system. This stabilizing system keeps the colloidal particles apart from each other. Now let's see classification of colloids. Depending upon the nature of dispersed phase and dispersed medium, colloids are classified. If the dispersed phase is solid and dispersed medium is liquid, then the name of colloidal system is Sol and the example of it is paints. If the dispersed phase is liquid and dispersed medium is solid, then the name of the colloidal system is gel and the example is jellies. And if the dispersed phase is liquid and dispersed medium is liquid, the name of colloidal system is called emulsion and the example of this is milk. When colloidal solutions appear like a fluid, it is called as Sol. And when the colloidal solution appears like solid, It is called as gel. Let's see some applications of these colloids. First, emulsions. Medicines, articles of daily use like milk, ice cream, butter, coffee, fruit jellies, cosmetics like hair creams, skin, ointments, and cold creams, and latex obtained from sap of various trees are emulsions. Now, gels. Gelatin and agar-agar gels are used in laboratories. Silica gel used in laboratory is dehydrating agent. Solidified alcohol is gel used in picnic stoves, and boot polish is also the example of gel.